Section 6.1, talking about Riemann sums, just introducing the idea of approximating area under a curve. Yes, 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 we can do A1, A2, A3, A4, A5, add them all up, which is what we were trying to simplify here. But Jason brought up the idea, isn't there a thing called a summation that is supposed to simplify repeated addition? And the answer is yes, but how? We have to put into the summation a formula that would model what's going on up above. True? True. Now, the one that Jason came up with does work because he started at 0, and if you add 0 plus 0.5, or 1 plus 0.5, 2 plus 0.5, 3 plus 5, you will go ahead, sorry, 0.5, you will go ahead and get each of those quantities. My question is, would this apply, would you be able to apply this if I change something like making the interval from 0 to 6?
Yes.
Wait.
No.
What would change if I change it from 0 to 6?
Well, then your tick mark.
My tick marks would no longer be by ones, my tick marks would be by
6
6/5. So 1.2?
Yes, you're going to use 6.5.
So question, pause, what would be the midpoints if it was going by 1.2s? Can I go make a number line real quick? If I was to go, pause, sorry, I want to show you guys some things on the board so it's not just all those who are able to only verbally track. Blah, 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 blah.
Do the curve.
Sorry.
That's okay. I did.
So then my delta x would be 6/5. So then my number line, I'm going from 0 to 6, going by 1.2s, right? And then I'd have 2.4, and then I'd have 3.6,
4.8.
4.8, and then 6. Imagine that's equally dispersed. Anyway, so,
You put 1.
oh, thank you. Thank you. What would be the midpoint of 0 and 1.2? 1.6. How about the midpoint there? 1.8. Uh-oh.
1.8.
It's not even anymore. This formula would be debunked. It would just be, how am I going to do it this time if my midpoints would be, let's go and mark them real quick. 0.6, 1.8. What's the next one? 3.0. You guys realize it's just like powers of, or, not powers.
6.
Multiplication of 6.
4.2.
4.2.
4.2.
And then between 48 and 60 would be 5.4. Okay. How could I get 0.6, 1.8, 3.0, 4.2, and 5.4 in here using a summation? But this time I'm going from
You change it
0 to 5. Or I could do 1 to 6. I do need something squared plus 1, but how am I going to get an expression that gives me those answers instead?
You gotta change the I, right? No.
I changed it to include one more. We could go from 1 to 6 if you would like, or we could do 0 to 5.
No, you have to do 0 to 5, because 1 to 6 would give you over 6.
Well, we do the first rectangle, second, third, fourth, fifth, and sixth. Oh, I only need 5 rectangles here.
Yeah.
So we're not changing the bounds per se. We could go from 1 to 5, or we could go from 0 to 4.
X plus 0.6. What would you multiply? What would you add?
But you couldn't multiply by 0.6, because if you did, you would end up getting these ones as well. So how do I just get every other?
0.6.
Every other?
Oh.
But 1 plus 0.6 is 1.6.
You don't
2
do the
plus
summation.
0.6 is
And
2.6.
you just do the above.
How would I get each of those?
Wait, then you don't start.
We are plugging something in. We do need to get the height.
Don't you have to start?
Our base is going to change. Did anybody figure that one out?
0.6x.
Yeah.
This one needs to be 6/5 or 1.2, right? That's the base.
0.6x.
Well, if you do 0.6 though, 1 times 0.6 is 0.6, 2 times 0.6 is 1.2. I don't want that one. I want the next one.
Is it? Don't you need to start with
Don't you have to start at 0?
I could start at
You
0.
make it a piecewise.
Wait.
If you go from 0 to 4 or 1 to 5, either one includes 5 different iterations.
0.6 plus 6, 0.6, so...
0.6 plus 0.6x.
No, because then I would have given you the first
That
one.
would still get you in between.
Wait, are we doing this for midpoint?
You don't do it, you just do it the
We need just the
original.
midpoint, so you just want 0.6, 1.8, 3.0. Question. What is, as far as multiplying, what would multiply to get 0.6?
Maybe point
1 times 0.6.
Wait, you just added.
What would this one be?
2 times 0.6.
Oh, negative? Wait, is that negative?
I'm multiplying, sorry, I'm trying.
Oh, wait, don't you just?
I need odd powers. So
Shoot,
how can
that's
I
what I was
represent
thinking.
odd? Thinking back to sequences and series maybe. How can I represent odd numbers and multiplying that by? Sorry, I'm seeing 1.6, I don't know why I'm doing that. 1.6.
Oh, is it x plus 1 parentheses times 0.6?
Almost. X plus 1, 1 plus 1 is 2. I don't want even.
Do it even though, right? 2 plus.
Wait, I'm just adding by one.
When you have 2 even numbers, you get another.
So I want to multiply 0.6 times, how would I get all the odd numbers? Not x plus 1. 0 plus 1 would work, but 1 plus 1 would be 2. I need 3.
Would there be a division?
No, not division. It's all based on a subtraction.
Minus.
Even have an odd.
2x minus 1?
Ah. Think of what Corey just said.
Or you're so smart. Plus 19.
Let's see if it works.
Am I right?
No, wait, hold on. 0 minus 1, that's a negative. I don't want that.
Square. Square.
Yeah,
It's
it's
square.
Well, but it's squared after I plug it in, but originally though, right?
Yeah.
Originally, that's still when, we want to make it so it actually works whether or not when you plug it in, it ends up being
Okay.
absolute value.
Absolute values.
Who wants an absolute value? We
Put
do.
a square in them.
Yeah.
You
Why
change it from
not
1 to
put-
5.
Why not plus 1 instead of
You change
minus 1?
Oh.
Corey, you're so smart.
Why not plus 1?
Or we
Plug in
can
0, I get a positive 1. Plug in 1, I get a 2 plus 1 is 3. Plug in 2, I get a 4 plus 1 is 5. Plug in 3, let's go. I get a 7.
Mind blown.
What if we did it from 1 to 5? Then could you do minus 1?
Yes.
Yeah, that would work too.
Yes, you could change your bounds from 1 to 5, then you could do 2x minus 1. Kiddos, in order to get even numbers, we have to, in order to get even numbers, just say 2 times x, we're fine. In order to get odd numbers, take the even 2 times x and either add or subtract 1. That way you have an even, take away 1 or add 1, you get an odd. Anyway, interesting, it will be helpful once we eventually get to where we need to solve using this summation.
Yeah.
But kiddos, for right now, maybe it was a little bit rough, but can you theoretically think of, when finding Riemann sums, figuring out a formula, when they're equally spaced, a formula that will allow you to find all the different x values that you're plugging in as or for the y values to get your heights, multiplied by your bases, and then with the summation you can solve without typing them all in? Yes. Could you type them all in? Yes. Both ways work. But this one leads us to the definition of the integral much better. Now I'm going to go ahead and take away all of this because is that technically our example? And the answer is no. So let's go ahead and move this back to what it was. So instead of having a base of 6/5, oh dear. Well, okay, we'll just get rid of all of it. Instead of having a base of 6/5, what was our base in this example again?
5.
Because 1.
1.
5 minus 0 cut into 5. We had a base of 1. A height, we're plugging into our original function, which is x squared plus 1. We're trying to get all of our different heights. Let's see if we can take what Jason did, but change the formula so that it matches the same idea as to what we just did when everything was shifted because I went from 0 to 6 instead. So what's a way that's not just a trick, but that takes what we just did and helps us find each of the midpoints? That does work, but we couldn't apply that to the next example, so it's not general. It's specific to this one problem.
2 times plus 1?
Oh, it's x plus, no, it's 0.5 plus 1x.
So, x
What?
0.5.
No,
0.5 plus x?
Or 2x.
No.
Wait, no.
No, it's not 0.5 plus 2x.
0.5x plus 1.
Times
Oh, I
2x plus 1.
2x plus 1.
doesn't this look awful similar?
And so isn't that just,
Wouldn't it be 1.5, 3.5,
but it's the same as x?
5.5, 7.5? I think this is able to apply even when I start changing my distances. All I need to figure out is
Or
what
is that you
the,
just changed?
huh?
Maybe you just drove it in something. Yeah, it's plus
No, I know, but
You just changed the 0.5.
Right, exactly. I'm just showing how this one I could apply when I change the interval. But how do I apply it? Where does the 0.5 actually come from?
The adding ones, the difference.
Increasing, you're counting by the midpoint.
Why was this 1.5 and the next one was 0.6? What changed?
Midpoint.
The difference between the 2
The
points.
midpoint, the difference between the 2 points. Another way of thinking about it is?
Difference between 1 point and the midpoint. Oh, the midpoint.
So C.
1 minus 0. And then 2 minus 1.
Right? But that one, I can't use 1 minus 0 in the next example. Wouldn't it have been 1.2 minus 0?
Yeah.
So how could I make it so I only have to use A and B? That'd be a lot nicer. How could I use 0 to 5 and 0 to 6 in order to get 0.5 and to get 0.6? How could I use 0 to 5 and 0 to 6 so I don't have to worry about splitting them up in intervals and then cutting it in half?
6
Final
minus 0 over.
minus
Yeah,
initial.
finest minus
Over
initial
the
over.
amount of money you have.
2, oh, 2
That's
times.
exactly how you do it. We basically just built the definition of the interval.
You just multiply top of 1 to 5.
My eye burns because I have hot sauce on it.
Because what you have to do is B minus A all over 2 times n. B minus A over 2 times n. 2 times, well technically we'll say C sub I plus 1. Plugged into the function, so f of that times the base, which is B minus A over n. Anyway, we'll see if you guys remember what we did today when we actually get to where we need to use it. Kiddos, if you see RAM and LRAM and RRAM and MRAM, can you figure out what's going on? What are those letters?
Left,
stand
right, and some, right, and some.
No, wait.
Left, right, and middle.
No, it's not.
That's
Located RAM.
for? Oh, left.
Wait, no, isn't it left hand?
L is gonna be for left, that's true. R is gonna be for right, M is gonna be for middle. What's RAM?
Area is A.
R approximation.
Something.
Approximation sounds good. Riemann sounds good.
Riemann approximation manual. Math.
Should have M stands for.
This is math.
No.
Math. Magician.
I mean, it's method. Okay, so Riemann approximation, that's basically what's going on if you guys see that. Right now though, when we're talking about this, hold on, a little low and a little high. Are we talking about over approximating and under approximating?
Yes, ma'am.
Right? Okay. APs like to ask about over and under approximations, true? What does this say about whether or not it's an over and under and what it depends on? What depends on, or what determines whether an approximation is going to be an under or an over?
Appreciates.
Yeah, how the function is
Concavity and if
increasing.
you're going from right to left.
Concavity?
Concavity, right?
Yeah.
Because it says based on the, what's it say? Shape of the curve. And specifically, here's the reminder, over and under approximations are based on concavity. Right? Now they go ahead and give you some examples in order to illustrate what's going on. To basically see which ones are going to be over approximations and under approximations. We could do that, which isn't totally bad, but since you guys have seen this before, let's go ahead and just go to, I don't want that one, a new page. And let's talk about Riemann sums. We can talk about something to the effect of types of approximations, or how it approximates. Okay, you guys said it's based on concavity, so I'm going to go ahead and show a concave up portion of the graph, just because. I'll do endpoints, because we usually have A to B, right? It's limited. I'm not making it super specific. I'm just showing a concave up portion. I'm going to show a concave down portion. I'm going to show a concave up portion. I'm going to show a concave down portion. Let's discover it, in case you couldn't remember before. Question, when will a concave up portion be an over approximation? What kind of Riemann sum would you need to be doing such that?
Not even some.
What?
Right.
To be an over approximation, we would need to come from the,
Right.
good. So we can say that When you have a concave up portion, a right Riemann sum will over approximate. If you have a concave down portion, what will over approximate that?
Wait, no, right, wait.
From the right.
Right.
All right, these kids are genius.
Give him 5.
Wait a minute. They're both right?
Yeah, because of the rectangle.
Did concavity make a difference?
No.
Concavity.
It's not based on concavity.
And.
Wait.
No,
Pause!
it's increasing,
But
decreasing.
regardless, it's still.
Increasing, decreasing,
Different
and
symbols.
concavity.
Pause. What would make a concave up portion under approximate?
Lead.
Uh-huh. Well, that's a rough one. I went down. Shh. Close the end down.
Forgive me. No worries.
So, hold on. And left would under approximate this one too?
It's just the sides?
It's increasing.
Exactly. It's not concavity, it's increasing, decreasing.
There you go.
The majority say concavity, so not with it.
I didn't know.
But wait, isn't it still increasing?
So, if
Oh,
the function is increasing, what's true about all 4 of these, or I should say both of these concavities? They're different concavities, but what's the same? They're both increasing. So we can say from that, when f is increasing, or we could say even when f prime is increasing, right? When f prime is increasing. The Riemann approximation, well, let's just use their abbreviations, that's nice. We could say LRAM, the left Riemann approximation. The left will always under approximate. And the right over approximates. Has nothing to do with concavity. If you want to think about it, you could say f prime, and then you're trying to find the area under f prime, which would be the antiderivative f. If you want, you can think about little f, and that's who you're taking the integral of. Basically, whoever it is that you're trying to approximate the area under, whoever is inside the integral, whether you're thinking about him as a derivative or as an original function. There you go. Oh, guys, I could show pictures, maybe I will quickly, but if that's what's true when f is increasing, what's going to be true when f decreases?
It's all around is over approximately right surrounding.
Good, everything switches. The left Riemann approximation will over approximate. And the right will under approximate. I was proud of you guys for thinking over and under and thinking concavity, and you were right, but not in this context, not with area and Riemann sums. What is dependent on concavity for over and under approximations, not area,
Tangent?
tangent line. If a function is concave up, the tangent line approximation, the local linear approximation, the linearization will always be an underestimate. If the function is concave down, the tangent line will be an over approximate. So concavity is important for tangent lines. Increasing, decreasing is important for Riemann sums. Or for area under, or for integration. Does that kind of make sense, guys? If I was to show a picture, just in case you're like, if I was to graph decreasing portions, whether they're concave up or concave down. Hopefully I could show you that if you came from the right, it's going to be an under. If you came from the left, imagine these are even, it's going to be an over. Just going with the same colors as up above. Going with the right is going to be under, going with the left is going to be over. Going from the right, oh no, left. Going from the left is going to be over. And going from the right. It's going to be under. Okay, that was a quick reminder. with over and under approximations. This activity would have had us do that. You would have had to throw functions into your calculator, solve for lots of different Riemann sums in order to find basically the exact same thing. So over and under approximations, Riemann sums based on increasing and decreasing. To end today. I think it's to end today. The next page is homework, right? Let's solve it. Volume of the solid hemisphere. Of a radius 4. Imagining its axis of symmetry is the interval 0 to 4 on the x-axis. Partition. What does partition mean?
Parts.
Split into parts, aka section. Section it off. So each of the subintervals. Partition it off, section it off. Form your subintervals from. That's what partition means. Into how many subintervals?
8. I'm on my point 5.
Of equal length, that's nice, and approximate the solid with cylinders, ooh, based on the circular cross sections of the hemisphere perpendicular to the x-axis of the subintervals left endpoints. There's a picture to help. Yes, it's 3-dimensional, not 2. Hence why they're talking about cylinders.
Pi r squared times height.
Pi r squared times height is the
Right?
volume of a cylinder, right?
Isn't that also right?
So we're not just doing areas, we're doing volumes. They're having us go a little bit deeper, still using approximations, still using subintervals, but now expanding it to volumes and not just areas.
So we plug everything with the pi r squared times height.
Minus some.
We have to do plus or minus, so you have 2.
You can expect pacific.
We're going to be doing 0.
0, hopefully not. I see some volume there.
Because the positive and the negative,
Is this like a
would
washer?
they not cancel out?
Kind of, but it's not actually solving with washers, it's approximating. So we're using the idea of Riemann sums, but to approximate volumes.
That's what pacific though.
Alright, find the y value.
Okay, but isn't there 2 equations that we're using it? Because there's the positive square root and the negative square root.
And why would they not cancel out?
Do we need the positive and the negative square root though? What are you looking at? Aren't you looking at, because we have little cylinders, these are little discs, right? We're going to take this little guy off to the side and like turn him a little bit. He would be like this with like a little depth and a little depth. He's like that.
That's a
We
really
were to
good
take him out and then we were to rotate him. So he's a little cylinder, and the little cylinder has a radius, right?
Oh, we have to double
And he has a height.
Oh, we have to,
Oh, and the height's
We have to
double
go
the height.
down for the radius. We don't go
we
up
have
for
to
the
double the
radius.
height, right?
Is that better? So then the radius, what would the radius be?
0.5. I don't know.
Ooh, it's a function value, isn't it?
Oh,
3 point, I'm sorry.
height.
Wouldn't the radius be f of 3.5,
That's not what she said.
Yeah. right? Wait, why are we going by 0.5s? What did we split that 0 to 4 up into?
8.
Oh, so if you go from 0 to 4 and split into 8s, 1, 2, and 3, we have to cut them into halves, right? Okay.
Yeah.
So then we have 3.5 here. What's my height going to be?
Oh, 0.5.
0.5, it's just going to be a half. Okay.
Yeah.
So when we go to do
So
S
we
sub
need
8,
more.
we can say the sum of these 8 different ones would be V1, V2, V3. Could we go ahead and actually split these all up and add all 8 of them together and find each of their radiuses and each of their heights and plug them into pi r squared h?
You could. What,
We
I
could.
think they're overachieving.
If you want to try to think about Riemann sums, maybe we can make it a little bit faster.
You can take the heights up.
You can't take the heights out because all the heights are the same. So we could go ahead and say, okay, all the heights or all the depths, we should maybe say if that helps. All the depths are going to be what? 0.5, and that's all found from 4 minus 0 all over 8. That's equaling delta x, which is what we're calling h in our volume formula for a cylinder. So we could say, okay, so all of them are going to have 0.5 or 1/2. Okay. Now, ooh, can't we pull out a pi?
Yes.
Okay, let's pull out a pi too. So all of them are going to have pi. Can't pull out the squared, sadly.
Why do you not double the R? Because of the top and the bottom, don't you have to double it?
Oh.
Because there's 2 of them.
Because each disc only has one radius. So we're just going to use one
Then
radius.
what about beneath that?
But they don't coincide. So this one's gonna be 3.5, this one's gonna be 3, 2.5, 2, 1.5, 1.5, and 0. They all have different radii. So we can't combine.
So the squares cancel? The square and square would cancel, right?
The square root
When you
cancel
plug
this
in
side.
for R?
Katrina's noticing that since R is really a function value, if you think of plugging in the value to this this quantity, R actually equals f of, so you could write it, pi y squared h. Do you guys agree? Because R is really a function value, so R is really a y. So then if we plug in y squared, Katrina noticed, okay, well if you plug in y, isn't it the same thing as plugging in 16 minus x squared?
Square.
What's going to happen to the square root and the squared? It is going to cancel. So far we pulled out the pi and pulled out the h, it's going to be the same. But what's going to be in all of these?
16 minus
You have to still plug in 16 minus x squared. So for the first one, wouldn't we technically have, well, guys, what's the very first cylinder that we have?
0.
At 0 though, right? So that'd be 16 minus 0 squared? What would the next one be?
16 minus 0.5 squared.
Is this going to work? And the answer is,
Yeah.
wait, not 1.5, we skipped, it's just 0.5, right?
It could work, but you know, it's better
Well, either way, it's work.
16 minus 1 squared. Oh, I struggle all the way up to 16 minus, who's our very last one? 3.5 squared.
all the power of 1/2. Which is how we
Okay, could you plug that in your calculator, the whole shebang? And the answer is yes. Has anybody figured out a summation that would do the same thing?
2x plus 1. I just worked for it.
So,
How many rectangles are we doing? Or how many subangles? 8. So 0 to 7, right?
So 1/2.
so
We can pull out the 1/2 pi.
Don't you also,
Times 16.
no, you already did. 16 minus,
Okay, how are we gonna get 0 and 0.5 and 1 and 1.5 and 2 and 2.5 and...
You're starting at 0, so you want to have a plus 1, don't you?
25
Yeah.
times 2x.
Oh, but you're plugging in though.
Couldn't we do 2x plus 1 again?
You just do
Well,
0.5.
question, on this one, we're not doing midpoints. Do we actually need only odd powers of 0.5? Or only odd, how do you say not powers? Odd. We need factors?
So we'll do 0.5.
I need 1.5, no, sorry, 0.5, 1.5, 2.5, 3 point, we didn't keep going.
It'll be 0.5x.
Yeah, you don't have to have every other one, because it's not a midpoint. Midpoints are a little bit tricky because we have to do the whole like in between, so we have to include that odd, 2x plus 1, 2x minus 1, depending on the bounds. But if we're just going from the left, or even similarly from the right, we actually don't need to worry about going in between, so we can just say, hey, isn't it going to be 0 times 0.5, 1 times 0.5, 2 times 0.5, 2?
Can we also put plus 5?
Oh my god. You could have just typed that whole thing in.
Well, could you have done x plus 0.5? Because then when you plug in,
No.
No, because careful, 0 plus 0.5 would be 0.5.
Because when you plug in 1,
And you're gonna miss the
you're
0.
skipping.
And when you plug in 1, you're gonna skip him, you're gonna go straight to
I'll be this, I'll
1.5.
be to the right, right?
So with,
That's a big one.
for left and right, is it just, no, not 0.5, is it just delta x times x that goes in,
Oh, like, this is the, Alan's gonna say this is our left Riemann approximation for this volume. Guys, what would change if it was a right Riemann approximation for this volume?
Oh, it's interesting.
I can see how it should be, but.
Because it's still cut into eighths, right? So we're
You just
still
go from
bound
1 to
by
8.
1/2.
Just go from 1 to 8.
It's gonna be.
Just go from 1 to 8.
You're gonna have to plug in.
Go from 1 to 8.
minus 0.5.
Why is Corey saying go from 1 to 8 and keep everything else the same?
Because then you just move everything over to 0.5.
Watch this summation.
Can I literally just change it from 1 to 8?
Yep.
Because wouldn't one say, hey, it's starting at 0.5 and it's gonna end at, what's 8 times 0.5? So it starts one in and it ends at B, whereas this one starts at A and it ends one away from B.
Oh.
Anyway, once again, could you've written the whole shebang out and typed it all in your calculator?
Totally.
But did you need to?
No.
What did you, oh, you updated in order to include some stuff? Oh. Jason's having fun programming over here. Okay, kiddos, let's go ahead and write down the homework assignment, sound good?
Yes, ma'am.
Write down the homework assignment. So, chapter 6, section 1, in your spirals, unless you already wrote it down, you already started last night.
Yeah.
I know you guys too well.
We were reading the chapter last night.
Yeah, exactly.
Alright, write down homework.
Top one there.
Oh, wait, check your numbers, I was off last chapter, can you guys double check which one should I do? What?
I already wrote.
It's okay, I'm fixing it on here.